The overall goal of this procedure is to demonstrate the manipulation of liquid metal under the influence of electrochemical potentials.
This method tunes the interfacial tension of liquid metal over an enormous range while elucidating the role of oxides on interfacial tension.
The main appeal of this technique is that it's simple, it's reversible, and it only requires very modest potentials.
This technique has been utilized to make electronic devices that are reconfigurable and composed almost entirely of soft materials.
To perform oxidation, pour an aqueous electrolyte into a petri dish. Use a volume that will fill the dish to a depth of approximately 1 to 3 millimeters. Use a syringe to place a drop of a gallium-based alloy in the electrolyte. Here, eutectic gallium indium is used. Place a copper wire with a diameter less than that of the drop into the liquid metal to establish the working electrode. In acid or base, the liquid metal will wet the copper and thereby form an excellent electrical contact. Place a conducting counter-electrode in the solution, but not in contact with the liquid metal. If the counter-electrode has a resistance of less than 1 ohm, its dimensions are irrelevant. Next, connect the wires to a voltage source and apply a positive potential to the liquid metal. For small shape deformation, apply positive voltages less than 1 volt. For larger shape deformation, apply greater than 1 volt. To perform reduction, dispense a drop of the liquid metal from a syringe into an empty petri dish.